This video is to demonstrate the use of Excel matrix functions to assist you in solving a matrix equation of the form that you see in the upper left. I will be demonstrating the use of these functions and how you can use them in order to solve the equation. First, let us define three matrices: a matrix A, a matrix X, and a matrix B. Matrix A we'll call the coefficient matrix. It is made up of the coefficients of the variables on the left-hand side of the system equations. You will notice that the system of equations, the coefficients of X are 1, 5, and 3, and you'll notice the first column of matrix X is 1, 5, 3. We do the same thing for the coefficients of Y and make a second column and the coefficients of Z in the third column. We'll also define a matrix capital X in which we will store the values for X, Y, and Z. It is a 3 by 1 matrix. Finally, we define a matrix B, which will contain the constant values from the right-hand side of that system of equations. Okay? We can solve this matrix equation, A star X equal to B, by first defining or finding the inverse of A. And here I've denoted it as A prime. Okay, and you will recall the inverse of A. You will recall in class and in your reading that if we have a system of equations of A, matrix A times matrix X equal matrix B, we can multiply both sides of that equation by a matrix A prime. And so we can modify equation 1 into equation 2 by performing that multiplication from the left-hand side of A prime, or A inverse times A times B, and we know it'll be equal to A prime, or A inverse times B. But you'll recall that A prime times A is equal to the identity matrix, because that's the definition of what an inverse is. And so in equation 2, we can replace the product of A inverse times A with the identity matrix I. So our equation 2 becomes equation 3, where the identity matrix I times the matrix X is going to be equal to A inverse times B. But furthermore, we know that the identity matrix I times the matrix X is going to yield the matrix X. That's because that's the definition of what the identity matrix is. Consequently, equation 3 will now yield equation 4, which is exactly the equation we're going to use in order to find the value for X. Okay? So the first step is to write the identity matrix, or the system of equations, in those matrix forms, and I have done this here. Here's the coefficient matrix that made up of that we called A. Here's the matrix X, and here's the matrix B called the constant matrix. So the first step I'm going to do is I'm going to find the identity matrix, or the inverse matrix of A. And we know that the inverse of a 3 by 3 matrix is going to be a 3 by 3 matrix. So I am going to select a 3 by 3 square into which I'm going to ask Excel to place the identity, or the inverse. Okay? And once I've done that, then I go up to the function bar and enter an equal sign to tell Excel I'm going to compute. And I want it to use the function of a matrix inverse, and finding an inverse function in Excel is called M inverse. So I enter M inverse, open parentheses, and you'll see he's asking for an array. The function, the array it's looking for is array A. So I will highlight array A and tell it that's the matrix I want you to use. I'll close the parentheses, and in order to instruct Excel to perform that function, I respond with Control Shift Enter. And when I do that, you'll see that Excel placed in the location that I indicated a 3 by 3 matrix, and that will contain values that will. So now, in order to find the value of x, I simply have to multiply the inverse of A, which I just found, times the matrix B that I defined earlier. When we know a 3 by 3 matrix times a 3 by 1 matrix is going to produce a 3 by 1 matrix, so I select a 3 rows and 1 column in which I want it to place the product of A inverse times B. And in order to perform the multiplication of A inverse times B, I use a function called mmult. M-M-U-L-T, open parentheses, and now it's asking for 2 arrays. The first array I'm going to give it is A inverse. So I will select A inverse, enter a comma, and then I'm going to select the second matrix, and that's going to be matrix B. So I select the 3 by 1 matrix B, close the function up with a right parentheses, and now I want to instruct Excel to perform that multiplication, and I do that by hitting Control Shift Enter, and there you will see the values we claim are the values for x that will satisfy that system of equations. Let's check to make sure it's true. In order to do that, we will multiply A, the original coefficient matrix, times the values for x that we claim are the right answers, and if they are, then we should produce the matrix B. So let's do that. So let's find the product of A times what we now believe is the solution, matrix of x. We select the 3 by 1 matrix for there. Again, we're going to use mmult as the multiplication of 2 matrices, but this time I want to select matrix A, comma, and then select matrix X. And if indeed those are the correct values for x, then when I multiply them together, I should find in the selected area a matrix that is equivalent to matrix B. So again, tell Excel to multiply with Control Shift Enter, and when I do, you see we have A times the matrix A times x is exactly the same as matrix B. So we have solved the problem. Okay? Not only is this going to solve the problem for this specific system of equations, but because I used matrices the way I did, it will actually solve any 3 by 3 matrix. So watch the inverse and watch the values of x and y. If I change a value in the A matrix, let's say instead of coefficient 1, it was coefficient 3. And so now the system of equations, the first one is 3x plus 2y equals 3z. And if I do that, watch the inverse, you see the inverse changed, and you saw x and y changed. And you'll notice, okay? I could change any one of the elements in matrix A, or could change any one of the matrix B. Let's say in the first equation was 3x plus 2y plus 3z is equal to 14. So if I put a 14 in there, you will see, surprise, it did change. Excel is telling me that the column wasn't big enough to hold the answer for 30B, so I'll just widen that column a little bit. And there's the value for x. And you'll notice that my test also proved to be true. Okay? Well, it not only works for 3 by 3 matrix, it can also be done by a 2 by 2 matrix. So here I have a system of 2 equations and 2 unknowns, but I do exactly the same thing. I define the coefficient matrix of A, which is the coefficients of the x and y's respectively in the original system of equations. Define matrix X, where I'll contain the answers I'm looking for, and then I'll create the constant matrix of 6 by 6, the constant matrix containing the constants. So in order to find the inverse of A, step 1, I find a 2 by 2 area, because that's what I know will be the size of the inverse, and I find M inverse. I select matrix A because that's the matrix I want to find the inverse of. Close the parentheses, Control Shift Enter, and there's my inverse. In order to find x then, according to our method, I'm now going to find the product of this inverse of A and multiply it by this matrix B, and that should give me the values for x. So I select the 2 rows and 1 columns for the size of x, and I want to multiply, so I use mmult, open parentheses, and I want to multiply the inverse of A by the constant matrix B, close with a parentheses, Control Shift Enter. There's my proposed solution for x of 1.7143 and 0.04286. And to verify that it is indeed the answer, I will verify it by saying I'm going to take the original coefficient of A, multiply it by what I think are the values for x and y, and see if I produce the constants that I'm looking for. So selecting where I want the product to go, I use mmult again, but this time I select matrix A, and I want to multiply that by matrix X, because that's my proposed solution. Close the parentheses, Control Shift Enter, and sure enough, there we have. So on this simple spreadsheet, to sum it all up, I now have a means of solving a 3 by 3 matrix and a 2 by 2 matrix. There is no reason that you couldn't now, on the same sheet, define a section where you can solve a 4 by 4 matrix, 4 equations and 4 unknowns, or 5 equations or 5 unknowns, or 16 equations and 16 unknowns. This concludes this video.